in pretty much a unique position in that for the first time we've got a company coming along talking to us. I would think that for the last 72 meetings we've had people and individuals talking, but never a company. So we're indebted to cyber technology for making the effort today. It's really appreciated, and I'm sure you'll be impressed by the time these two gentlemen will have finished. So we have Paul Dewar and Joshua Portlock. Would you both like to hit your feet, please?
Sure. Thank you.
Paul, on my right, the big one, has been with cyber technology since it was first formed in February 2007. He's mixed up in communications engineering, that's his backbone, and he reckons he's an RC, that's radio controlled loony. We've got one in the front here, Stan Scher, he's a bit of a loony with his RC aircraft as well. So thank you for making the effort to come along today. And, I've been to the factory and seen what goes on down there, and I was blown away, as you will be today too. And on this side, the thin one, so you can recognise who's who, is Joshua Portlock. Joshua has been with the company only 2 years, but since maybe 5 or more years ago, he's been playing around with an idea which grew in his mind to do with a quad. And he'll tell you what the quad's all about as time goes on, and maybe do some amazing things. So without any further ado, I'll turn it up. It may take us a couple of moments to get the computer sorted out, but without much further to say, we'll have a look at unmanned aerial vehicles as produced and developed and manufactured and sold by cyber technology. Just over the road here, down the next couple of suburbs away, River Lake. So over to you, gentlemen.
Thank you. Funny questions about why I'm wearing this. I don't know whether you all know, it's National Canteen Day today, National Bandana Day. Canteen for Cancer Research. I'm Paul Dewar. I represent cyber technology today. We're very pleased to come along and talk to you today. We're one of the few specialist companies in Australia that work in the UAV industry. In fact, we think we are pretty much specialists in the field. And I'll give you an insight of what we do today. We'll try and keep it brief. We'll look for questions and answers towards the end, but please, if you do have a question as we go along, please ask. If I don't cover anything for you enough, that sort of thing. I'll start off and then Joshua will take over from there. Simple company background. We started off with research and development. The Managing Director and Chief Technology Officer, Chris Monkley, who couldn't be here today, unfortunately, apologises. Initially started out working with myself. We've been involved in operating drones for the Australian military targets, where they shoot them down using shoulder-fired missiles, that sort of thing. And Chris had quite a few numerous ideas in regard to where he could see the development going in regard to unmanned aerial vehicles. A typical target that we manufacture here, you'll notice it's a gas turbine powered target. We also do propeller powered piston engine targets. The Cyber Quad, which you'll see more of today with Josh. This is our Cyber I-2, our surveillance aircraft, and one of our special development aircrafts that we've manufactured for the DSTO in South Australia. The Defence Science Technology Organisation over there is developing a new type of missile seeker head. I know it's going to get a little bit techo, I can't help myself, but they're developing a new seeker head that's based on insect vision, a number of different video cameras all grouped together in one focal area. They'll be installing that in the front of this aircraft, and they'll be using this aircraft to test that system and see how it works. So it's designed to acquire a target, track a target, fly the missile to the target. What they'll do is they'll use the aircraft to accomplish that and develop it before they actually install it in the missile and destroy it. So it's a reusable platform for them. We've developed 3 of these for them. Capable of about 300 knots, it's about 3 metres long, 26 kilo gas turbine engine in it. We operate and provide solutions, as I've spoken, in regard to various organisations throughout the world, DSTO, DARPA, etc., etc. We have a little logo that we carry around on a number of our vehicles and computers. We call ourselves the Wombat Works. Lockheed Martin had the Skunk Works, Boeing had the Phantom Works, so we have the Wombat Works. That's just something that we like to attribute to Australianising ourselves. We have aircraft operating with Thailand, Malaysian armies, Australian Police, TRG, Forensics, Bomb Squads. Recent acquisition is the Melbourne Fire Brigade with quads. A lot of the applications that you'll see we're involved in, oil and gas inspection. Josh will cover a little bit more of that in regard to a certain oil rig up on the northwest coast. Infrastructure inspection for Western Power, you'll see some video in regard to that. Aerial photography for real estate agencies. Willie Porteous wanted us to fly through one of his houses with a quad to provide a different way of presenting video of a house. External video of a house, fly-throughs through backyards, overviews, that sort of thing. Aerial cinematography, music videos. We've been involved in groups filming music videos and doing some aerial photography for them. Documentaries for the Discovery Channel in regard to the dolphin slaughter. We were doing some flying for the Discovery Channel in regard to that, and we'll do more flying for the Discovery Channel. And as I mentioned, the Metro and Country Fire Brigades are looking at the quads and various other technologies. I'm more heavily involved on the heavy aircraft side of things. Cyber 2 is an aircraft that we operate reasonably frequently at our local aerodrome here. You may recognise it if you've ever flown into Beverley. We're members of the Beverley Soaring Society. We have a very special privilege of being able to operate out of that site through Mondays to Thursdays. We'll go down there and we'll do some test flying. If you're ever flying in, listening for our radio calls, we'd be happy to talk to you. We don't fly with other aircraft in the area. We'll land and get out of the way or whatever, but we're very lucky and very privileged to be able to operate out of that site. Because this aircraft is 4.5 metre wingspan, maximum takeoff weight of about 70 kilos, carries enough fuel to fly for 10 hours, and it can be operated fully or semi-autonomously. That means it can be either flown manually by a manual handling pilot, or it can be allowed to do automatic takeoffs and automatic landings fully autonomously. It's guided by GPS, and so we can locate a GPS position on a map and locate another position and look them all up together and send the aircraft off and go and fly a flight plan over those GPS points. 70 kilometres typically data link range and 50 kilometre video link range. What that means is we can command and control the aircraft out to 70 kilometres. We can also tell it, no, we don't want to know what you're doing, we'll send you further away, and it'll just go and come back when it's ready. The 50 kilometre video link range means that we can beam live video from the aircraft to the ground, and so we can see that live video. So if we want to watch the live video and we have a camera operator sitting next to us when we're operating, who actually controls the camera, pans, tilts, zooms, does what the guy in the funny uniform next to him says, I want to look at that. That's the sort of range that we operate in. Alternatively, we can again set up the camera within the aircraft to do things and just send the aircraft off and let it do its thing.
What altitude?
We're typically limited to about 10,000 feet, mainly because we're operating with a carburetor, piston engine, and it's limited to basically the freezing point. We're working on that one as well, specifically in regard to inquiries we had for operating at airfields that are higher than 10,000 feet at some other location on the planet. That's about as much as I can talk about. We've done some other flying around Perth that you may not be aware of. We've flown over Coburn Sound. We have an operational NOTAM that we can have issued within 48 hours notice up to 1,500 feet over Coburn Sound, up and down the coast up to Hillary's, out to Rottnest. So we've done some demonstration flying. This is based out at the Australian Marine Facility down at Henderson. We were taking off and landing off this road here, and we were doing shark watch, we were doing search and rescue, man overboard, that sort of thing, demonstrations. And that's Cyber 2 on approach autonomously. Again, operating out of Beverley, you'll notice the very high angle of attack and steep climb out. we can operate from very small areas. We can do very steep approaches and very steep takeoffs, flying manually, and so therefore we can operate off virtually unprepared sites, roads, whatever, and recover the aircraft into that area. We can also recover the aircraft by parachute as well. We carry the parachute in the top hatch here in the engine cowl, and just pointing out here in the nose, you'll see that's the camera. It's a dome hanging underneath the front of the the front of the aircraft. The nose gear is retractable, so it retracts up into the fuselage and gives the camera unobstructed view all the way around. This is where I'm going to hand over to Josh, his specialist area, and what Josh has been able to do is to take his thoughts and concepts and turn that into a very, very clever and special product. Thanks, Josh. Thanks, folks.
Thanks, Paul. Thank you all for having me here. First of all, very privileged to be presenting to so many experienced aviators, particularly given I'm by far the youngest person in the room. But no, it is an honour, and I hope you found what I've done quite interesting. Okay, so looking at the industry at the moment, or over the last 5 years, the unmanned industry has been growing a lot. As Paul's shown you, some of the larger or medium-sized unmanned aerial vehicles have been gaining a lot of commercial success. But what I've been researching is more the smaller, more compact transportable vehicles. And if you looked at what was out there 5 to 10 years ago, open quadrotors were emerging where they have 4 propellers, electrically driven, brushless, usually direct drive, so no gearboxes or no engines, fuels, so very low maintenance, low cost. And that's great in terms of the simplicity and ease of operation, but there's definitely a safety issue related to usually carbon fibre blades spinning around, and if they're trying to fly near people, it's definitely not ideal for operating over crowds and areas where you could potentially have an accident and injure someone. So I was definitely focusing my research on ducted fans and looking what's out there already. There are single ducted fan aircrafts in the military, costing in the hundreds of thousands of dollars, because usually they're internal combustion, quite complicated with the control surfaces, a lot more challenging to fly stably and robustly compared to a quadrotor. So you could call what I've developed more of an evolution and a combination of existing technology, but optimized in a way that it performs the job well and satisfies the requirements for both sort of industries. Military going more for the ducted fans usually, civil and commercial applications interested in the quadrotors because of their lower cost nature, where the Cyber Quad combines the best of the both worlds and makes a fairly low cost, very capable, safe, compact platform for aerial photography, cinematography, and various other applications that we'll demonstrate. We offer so from the evolution of my research prior to joining cyber technology, okay, I'll stand on this side, but you'll see over there's the Mini and the Maxi. The Mini is a more compact, transportable version, and it's more targeted at the law enforcement, special forces, tactical reconnaissance type applications because of its compactness and ease of transportability. You can fit 2 inside a small rugged case that you can fit in any vehicle. It's check-in size, luggage size, and backpackable if desired. We offer various payloads that bolt on the bottom for different applications. And then the Maxi was the second generation, which was more targeted at the payload, looking at the quality of the footage, so focusing on high definition video cameras like the one on the table. The one Paul's holding up is the digital SLR, so that's for aerial photography applications. And we also have a combined thermal optical payload option. So with the one platform, customers can choose what payload they mount in the front there, and you get a nice unobstructed, visible control range of the camera, and it's gyroscopically stabilized. So even if you do have to fly quite agilely in certain applications, the aircraft is always maintaining the tilt angle of that camera so that it's targeted accurately onto what you're interested in photographing or videoing. So basic system, we provide fully packaged up in rugged cases, usually for that military law enforcement customers want everything ruggedized, but even for the cinematographers and industries that want to look after their equipment, we have it all tidily packed away, all in the one case. You can stack 2 in there. You've got your standard charge case, your vision terminal, which is a like 10-inch daylight visible screen, your controller. So from your main controller, you can control the aircraft to fly up and down, turn left and right, which turns the payload effectively, push the aircraft around in pitch and roll. But one of the main technology enablers that make these vehicles at all flyable and easy to fly is the stability control systems. So you're almost all familiar with autopilots. These are just miniaturized versions that electronically keep the aircraft very stable, and no matter what you command the aircraft to do, it'll keep itself level. So pitch and roll angles are electronically limited, so that you can't flip the aircraft. So you don't have to be a competent helicopter pilot to fly these aircraft. Then we have things like GPS upgrades to hold position, and even more advanced fully autonomous waypoint navigating as well, so that you can just set a path and do grid patterns for aerial surveying activities or various other surveillance, border security type missions. And then the operator can either wear video glasses, which plug into the controller, and they can see what the aircraft's seeing, so they can fly first person, as if they're sitting in the aircraft, like being the miniature pilot on board. That's more for customers that are wanting to be portable. They can walk around with the controller, and they can get up the aircraft into a sort of more cumbersome area, aim the camera where they'd like. But for cinematography applications, we tend to use the vision terminals, which is like a high brightness screen, so you can use it outside. Many people can be watching what's going on, so like the work with Discovery Channel and other music video and cinematography groups. Many people can be watching what the aircraft's seeing, so a director can have some feedback in real time to the pilot. You can also do dual operations, so one person controls the aircraft, the other person controls the payload, so you can accurately fly the aircraft around with one person doing the position and the other person tilting. So we're basically very commercial focused. We rely on customer feedback and the applications that emerge to tailor our solutions to their needs, rather than trying to square plug round hole our technology into a bunch of industries that might not be suitable, where ground robots could do it better, or other technologies, or even manned aviation is still more suitable. We focus more on the applications where it's too dangerous to use manned aviation, flying low altitude with conventional helicopters, anywhere where you don't need a person in the sky, obviously. If you're just carrying a camera, you don't need all that weight of a full-size helicopter carrying people. And particularly rope access applications, where inspecting assets where people are normally having to climb up and down and risk their lives. You don't need to be risking people's lives to get to those relatively low altitude, but still hundreds of meters up and on a rig of some sort. You can fly these aircraft up and have a nice close inspection and see it all from the ground. I touched on the levels of autonomy, but just to summarise again, you can just fly the aircraft manually with it electronically limiting its tilt angles and altitude control, rate of climb and descent. And then we offer upgrades to do position hold, so that you can fly it out to an area, flick on position hold, and then just act like a temporary CCTV station and just pan the aircraft around, tilt the camera, zoom in, take photos. And then flick a switch if you're disorientated, you're not sure where it is, you just flick return home and it will fly back to you, which is convenient. And then the fully autonomous variants allow you to use a laptop similar to what we do with the Cyber-Eyes, the fixed-wing aircraft. You can set your waypoints and you can tell it to fly up and down, back and forth over an area, taking photos. And they can use that for various surveying and agricultural applications as well. I've touched on the equipment already, but a bit more technical information there for people interested in various radio frequencies and whatnot. But I know you're all probably dying to see it in action, so I'll play some videos for you first, and then I'll give you a little flight demonstration. Yeah, obviously it's a small aircraft, so it can be taken by the wind, and the GPS hold can hold it up to 20 knots wind, so beyond that you can manually fly faster, but it'll struggle to hold position, obviously. So we tend to recommend sort of less than 10 knots if you want accurate, stable video or photos, and just pick your times of day that's going to be more suitable.
Usually the limitations in regard to the operation that you're flying at the time. The aircraft is normally capable of operating in virtually any conditions, really. but it's whether you want a good image from the camera and that sort of thing. That's normally what limits it.
So these are various.
What's the power source?
So lithium polymer batteries, and typical endurance is 15 to 20 minutes depending on payload. And although that doesn't seem long, you'd be surprised how much video footage or photos you can take in that time. And then if you need to keep flying, you just land the aircraft, change the battery in less than a minute and be up in the air again. And then it takes up to an hour to charge the batteries, but we usually provide 4 or 8 batteries so people can do several missions in a row. Now this is an inspection application to show you the UAV can safely fly close to power poles because it's an engineering plastic as opposed to a carbon fibre. It's non-conductive, so even if you do get too close to that to the power poles, you're not going to cause a fire. And this allows the operators to get a close viewpoint of the conductors in a quick and an efficient way compared to having to get cranes up there or forklifts or whatnot, or having to call in helicopters to fly in and get close, dangerously close, and disturb everyone with the downwash and whatnot.
What's the battery recharge time?
Up to an hour, depends how much you've discharged the battery. We can fast charge them in like half an hour, but it reduces life, so we tend to just look after the batteries. And you can charge them off a car power supply, so you can have, we provide in the standard kit 4 batteries and 2 chargers, so you can just keep topping them up while you're operating, and just fairly continuous cycle that way.
Noisy?
No, it's only about 65 dB for the Mini within 3 metres and 70 dB for the Maxi within 3 metres. I'll give you a little hover of the Mini in here to demonstrate that. But beyond, in here you'll get a lot of reflection and noise, but outdoors beyond 30 metres you can't even hear it, so it's very unobstructed.
Are there any latency issues between command and response?
No, so with the video and control systems we use a very low latency, sub 100 milliseconds, so it feels like you're at the control stick yourself, pushing yourself around. The only teleoperating limitations that you might be thinking of is more like the fact that you're flying through a straw, as opposed to having the great peripheral vision that pilots are used to having. So that's a bit of a different mindset of getting used to flying from glasses or a terminal. You've only got this limited field of view to gain your situational awareness, and it's typically 2D. So even though you can quite accurately and quickly control the aircraft, you more have to worry about, am I too close to that, or am I drifting backwards into something, and those sort of things that you wouldn't have thought are an issue. Now this is a sort of tactical response application, being able to hop into a building and just do a little reconnaissance.
You hear a knock on your door.
And this little buzzing bee sound out the side. Right? So tactical response units, and I'm afraid it's not playing in real time up there, but tactical response units are quite fond of that idea of being able to fly around urban environments and assess the threats before sending people in. You can avoid having someone's head blown off because someone's ready to shoot whoever comes through that door. You're much better off having your cyber quad shot at rather than a person, right? Now this shows some autonomy of the aircraft. So this is auto takeoff and auto waypoint. So you'll see, it's a real shame it's not playing in real time up there, but you'll see I'm not controlling the aircraft, automatically take off. You'd see on the display there it's got a moving map, so you basically click to fly on the map, click to take off, click to navigate. It's very easy to use. Not to say that we don't make sure we train people how to be pilots still, because we find it very important that as a fail-safe, if you lose GPS or you have issues with the waypoint, you still want to be able to manually take over and bring the aircraft down safely if needed.
Why don't they settle on 4 fans and not 3? And the analogy of a stool.
Yeah, that's a very good question. That's because stools live in the 2D world, whereas if you're trying to control something in 3D with 3 points or 3 degrees of mobility, then you can only control 3 axes. You can control pitch, roll, and altitude by the thrust, but without tilting or some other control surface, you can't yaw a 3-fanned aircraft. The way we yaw with the cyber quad is with 2 counter-rotating pairs. So you increase the one direction and decrease the other direction. Your net thrust is maintained the same, but the reaction torque, like a coaxial fan, produces a yaw torque. So by mixing the fans together, you get that pitch, roll, lift, and yaw 4 degrees of mobility needed to fly like a helicopter with only 4 moving parts. So if you did go for 3, you would lose the extra lift you could have gotten from 4 fans in a similar footprint, but also have the extra weight penalty of either a downstream vane or a tilt mechanism and just more cumbersome devices in there.
So do you sell the equipment or the service?
The complete solution as a package, and usually with training, to allow that particular industry to go do what they do best. So we have offered a service like this, for instance. This is the oil rig that burnt down off the West Atlas. And you can see how damaged that asset was, that they didn't even want to send people on there. They weren't sure how safe it was. So they commissioned us to bring 2 Cyberquad minis at the time. This is only mini footage. And if you'd like, come look at it in real time afterwards. But from the mini footage, they got to decide if it was safe to board even, plus make some preliminary decisions about scrapping or repairing or what they're going to do with the rig. So while the industries are quite new, and you can see we have been offering a service to get a feel for what those different industries would require. However, we are more of an R&D and production house, so we don't want to spread ourselves too thin by trying to service every one of the many applications we touched on. So we just do that as an initial PR activity, and then we build up the customer base based on that, and we are confident in our system to be able to service those needs. Then we train people to use the solution in the various industries.
So how do you stop people pitching your ideas?
Yeah, intellectual property is an interesting debate with this industry because it's a very fast-moving industry. We have looked at patenting aspects of it, but to be honest, as I mentioned, the quadrotors and ducted fans are nothing new. In fact, quadrotors were one of the first helicopter concepts back in the early 19th century. But they never took off, so to speak. They were like really struggling to get stability control and whatnot, and the advent of the sensors lately have allowed that to be possible. Ducted fans in the mid-50s were really popular in a lot of research, so again that's sort of been done to death to some extent, but it's more the use, the combination of the technology that is the idea, and it's the optimization of the components and all the different shapes, geometries and components used. So you can, I mean, we have design registrations, so we're protected if people try and copy the look and feel and design and form factor. But in terms of other people building ducted quads, they could, but a lot of people have tried and not really done a good job. So what we more focus on is having a really capable solution, not just the product itself, but a solution with all the packaging of accessories and components and payload options that we're way ahead of our competitors. And that's what sells our products and keeps us ahead. And then as more competitors, it's only inevitable more competitors will emerge. There are a lot of open quadrotors emerging out there. But as long as we stay ahead of the curve, which is typically a 6 to 9 month gestation period that we're continually improving our product, we'll always be ahead.
Do you write the software yourself?
Yeah, early days I did a lot of the software myself for stability control, and I still tune all the algorithms, but we've got a good team of engineers now that do all sorts of software development for the stability control algorithms and the autonomy. And we're also developing a lot of in-house hardware lately as well.
Are all the developed nations building this sort of thing heavily? Most funding would probably be the best one.
Not necessarily, actually. I find, well, personally, from my experience, the right team is much more important than the right amount of money. We've been able to do a huge amount with not very little. We've had some good investors, don't get me wrong, but with smaller budgets than, say, US companies and groups, we've achieved a lot more than the US groups. So, for instance, without mentioning names, you probably saw the shadowy ducted fan vehicle on the right, which I won't mention, but that particular company is a multi-billion-dollar company. They put over $200 million investment in that product, and it costs the military $250,000 per product, and they haven't really sold that many. We're probably getting close to the number of sales of Cyberquad they've made of that. But that's quite a big difference in what we're spending on and what our systems cost. So I think it's more a value proposition than it is how much development funding goes in, because the more, as with any investor, the more they put in, the more they want out. So they're going to expect bigger margins, and the value of the actual end solution is not going to be as good as if you can somewhat develop more capable on less budget.
Thank you.
With the range of ducted quad in the aircraft, you use EPIRB for recovery if you get lost?
We don't use EPIRB exactly, but we do have a GPS on board that transmits its location back. So with a laptop, yeah, you could go find it. But typically operations are within a couple of 100 metres, so usually it's like, oh, it went down there, let's walk that way and you'd find it.
What about the aircraft, 50 kilometres away?
Well, with the cyber quads, we keep them within within a couple of 100 metres typically, up to a kilometre line of sight with the control. But with the
with the cyber eye, it's providing telemetry back to the operator, so we constantly know where it is. We have GPS reporting on the screen, so it's lat and long and altitude at that particular time. So if we do have the aircraft go down within that area, we know exactly where it was the last time it communicated to us. And so that's also a requirement of being able to make radio calls, so we know where we are, and being able to report that over the radio as well. Just one of the things that we touched on there in regard to investment, we currently have a project that we're developing our own autopilot. So we have the technology that Josh has started the development with for the quad. We're currently using an autopilot that's manufactured out of Spain by UAV Navigation in the larger aircraft, and Chris and I have been working with that company for about 8 or 9 years. And the limitations of that technology is that it hasn't grown. There's been no future development for it. And with the technology and the people that we have available, we've decided to put together a team and fund development of our own autopilot. And that's coming into fruition now. We'll start doing some test flying next week of the actual autopilot system in an aircraft. We have a number of very dedicated engineers in regard to that. It's quite unusual here that we have Josh's uncle in the audience, one of our key engineers in the autopilot project, Morgan McDermott. I think his grandfather is over here, Ron. And so from that perspective, we've taken some investors' money and turned that into a product which will also be a product we can use ourselves to provide a service, use ourselves in providing equipment and being able to sell that product. And one of the things that we're capable of doing in regard to the latest technology is the GPS system in the autopilot will be capable of telling us where we are with an accuracy of 1 cubic centimetre. Now that's quite exceptional, and that's done through some work through some organisations here in Australia, providing us with some clever antennas, some simple and basic GPS receivers, and then some very clever algorithms done by some very clever software guys. And so you can see that taking that sort of technology is really based on the capability that you have behind it and the people that you have working with you. There's a lot of talk about all this stuff that's available off the shelf that we were referring to in regard to other technology, in regard to the quad rotor, and we've found that a lot of people have gone, oh yeah, we can go and buy this at something cheaper, or this, it's cheaper, and then all of a sudden they come back and we want to know why we're talking to them again, and it's reported that it isn't actually doing what it was supposed to be doing, or it isn't as reliable, it isn't as capable. And that's really what we do and what we are. We're a company that's working in the aviation industry, and so we're targeting the solutions that we produce to be reliable enough that you'd want to fly in it, even though you don't. And I think that's pretty important for any one of you here with your background in manned aviation, and also with the maintenance capabilities that we can keep it flying and keep it performing, and it will continue to do what we want it to do. And so as a company, we're investing in our own UAS operations certificate, so the company itself in the very, very near future will have the ability to provide services, which was a question that was asked before, rather than having to have a capital investment from a company to buy the product, especially the CyberEye, which is obviously a substantially more expensive product than the CyberQuad. And then we're also investing in the training and development of our own people to become UAS operators, and UAS being Unmanned Aerial System, which is the whole solution, not just the aircraft or the vehicle. And from that perspective, everything we do is compliant with CASA, their regs, their orders. Everything we do is kosher, if you like. And that's one of the things that we're very, very lucky in Australia to be able to have the ability to fly out at Beverley. We can go to Woomera, the Woomera test range. CASA is being very, very supportive of the UAV industry in Australia. There's a team of people who've been set up. I'm one of the members of the team to develop training for UAV operators and how we should base the training. Currently, to be a UAV operator, you have to have passed the flight radio operator's license, you must have passed PPLA or PPLH, and you must have IREX, so you must have done IFR work. So we're currently looking at that and saying, well, the poor guy who wants to go and operate a quad, who can fly not above 400 feet, no closer than 30 metres to the public and within visual range, and he's within the CASA guidelines, but he still can't be classed as an operator because he doesn't have all these qualifications behind him. And so CASA is supported by providing the capability for a team of people to get together from industry to help develop regulations and rules for training. We're also very supportive in that we can go and get a NOTAM to fly a UAV outside of controlled airspace, of course, that's one limitation, and in daytime, and they support that capability here in Australia. It's something that you don't have in the rest of the world. You'll read and see a lot about UAVs being operated by the military, but you'll read very, very, very little about UAVs being operated by commercial businesses anywhere else in the world. And so we're very, very lucky to have that sort of support here in Australia. We're also very lucky to have the support of you, to invite us along here today, to be able to talk to you, present to you. We've got some business cards up here. We're happy to give you that information out. Look at our website, please. If you want to contact us and come and visit the factory, we're happy to have people in and come and have a look at what we do. It's a nice operation. It's not a Boeing, but it's not a backyard shed either, and we're very proud of what we do. And again, I'd like to thank you very much for the opportunity of talking today, and appreciate any opportunity that you may see and anything we can do in the future, whether it's questions and answers or maybe even services. Thanks.
The operator runs it into a car pole or a tree or something, which was undamaged. What was the chances of recovering it back to normal flight immediately?
Yeah, sure. So, I mean, I'll be honest, we've hit power poles before, and it really depends on how quick the pilot responds. If it's just a basic bump, you can bump into walls and bounce off and it'll keep flying, it's not a problem. If you hit and tumble, then it's how quick the pilot can like thrust out of it and gain control again. It quickly tries to right itself, so it's trying to do that, but you've just got the time between the power line and the ground, if you can right itself in time and hover again. But even if you do hit a power pole and right the aircraft off, it's not a lot of cost in the sense that most of the electronics usually survives, and we can transplant them out of the airframes into new airframes. And we try to look after our customers in that sense. If they're going to be putting the aircraft in high-risk environments, they can usually send it back to us and relatively affordably we can refurbish them and get them going again.
We can bump into things, we can bang into walls with the quad and we won't damage the aircraft, we won't even interfere with the operations of the aircraft due to the stability and the shroud protecting the propellers. If you do happen to hit something, and usually you're replacing a prop. You've replaced the prop, you're back in the air very quickly. There was another one over there? Sorry.
We use a very rugged engineering thermoplastic, so it's quite durable, it can handle like a fair bit of a beating. And we've chosen the thermoplastic over carbon fibres for several reasons. The carbon fibre, although very stiff and light, which is great for structural members, if it's too stiff and not enough elongation for high impact scenarios where you're going to get drops all the time, you're going to come down hard and hot quite often, especially in windy environments. So you want to be able to tolerate that environment. I've built carbon ducted quadros before and a few bad knocks and then I'm just cracking and fraying and hard to maintain.
Yes, sir.
With the rapid advance in technology, do you find that you've got immediate contact with the firms that you want to take up your offers and things like that? Have they got the technology to understand your, generally speaking?
Yeah, most people who inquire about what we do are normally talking at the same level as where we're at, because they can appreciate what they want out of the solution. And so it's a reasonably level playing field from that perspective. You do get the inquiries from the hobbyist who may make an inquiry and decide he likes the quad and wants to buy one and have one as a Christmas present, and then immediately gets scared off from the cost. and then the cost is simply there because of the development that's gone into it and the technology that exists in it to do its job. And so yeah, we get that sort of level change really from that perspective only. And again, from the larger aircraft perspective, a lot of people certainly know what they're looking for when they're looking at those aircraft.
You haven't told us about all the sensors that you put on it for various functions.
Yeah, well that's very true. One of the things that I was watching when we were talking about the quad, there is a package that we actually put underneath the quad that has the ability to detect the various gases. So we can fly the quad into a chemical fire, for example, or into the plume of the chemical fire, and they can immediately report to us back at the operator station the type of gas that's being detected in the parts per million. We can also have another package which goes in there which detects weapons of mass destruction, sarin gas, that sort of thing. We carry normal video cameras and infrared cameras on the aircraft as well, so we can fly and use infrared at night if we need to as well.
You know, in high wind situation, would you
certainly, as I was alluding to before, the quad's a very, very capable aircraft in itself. It can fly up to 70 kilometres per hour, and it's virtually flying along like that, 4 ducks flying along horizontally. So the aircraft's very, very capable in handling those sort of conditions. But in the end, it's the solution that you're looking for. How still is the image? How good is the video? Is it usable? And so therefore it can be limited. If it's windy and gusty, you start to get a lot of movement with the small aircraft bouncing around a little bit and spoiling the video. Whereas the larger aircraft, the CyberEye, it's a gyro stabilised camera. It can also be stabilised through the Autopilot, so it's a very, very stable image. We're flying up anywhere from 2,000 to 5,000 feet, so we're out of that buffeting zone down near ground. And so the images can be much better. The only limitations we have in regard to the aircraft then is launching and recovering in those sort of conditions and where we're operating from. So yeah, we do spec up the limitations in regard to the system. Crosswind flying, no greater than 15 knots for CyberEye. So those sort of things, but from a capability point of view, I'd rather be on the ground when we fly these aircraft sometimes in the conditions that they're experiencing.
Is it electrically driven? Is it providing an ignition source of any sort?
No, it's they're actually brushless motors in the Cyberquad, so there is no ignition source. So it is basically intrinsically safe.
Except for when plugging in and disconnecting the battery, so just
Yeah.
make sure there's no gases while you're doing that.
That's right.
And then during operation it's
Good
fine.
point. Yes, sir.
With the CyberEye 2, how do you get on for traffic pollution avoidance if you're 50 k's away through uncontrolled airspace near towns or something?
Yeah, absolutely. We dedicate the payload to the camera to being able to be aware of what's going on around us. We can also add another camera system and another video transmitter to the aircraft to be dedicated to looking for see and avoid. So yes, we do have to take care of see and avoid. It's also nice to be able to operating in areas where other aircraft aren't necessarily supposed to be. And so we take the opportunity at the moment to utilise the camera payload for see and avoid, or we fly in an area that's been NOTAM'd out and predominantly no one will be flying there. So we're very lucky in regard to being here and being able to work with the local military organisation, if I can say that much, and where we go and fly.
What
you wouldn't be flying.
What danger is this getting into the wrong hands?
There are limitations in regard to the ability to be able to operate it. There are systems that provide protection internally in regard to being able to operate it. But there are a number of solutions around the world at the moment that are quite capable of being used by someone who would want to do something like that rather than just buying or acquiring something of ours. The data link that we use for CyberEye is fully, it's a digital data link, it's frequency hopping, spread spectrum. It's a mil-spec radio modem, you can't hack it, you can't steal it. It's ID protected and a few other protections as well. And sorry, just in finishing up in regard to the see and avoid thing, there is a radar solution being developed for UAVs, and see and avoid is very much a very big topic, and there's a lot more to it than that, but the capabilities are certainly limited just now, and that's why, as I said, we prefer to go and fly and operate in areas that have a certain amount of protection provided to us when we're flying that distance away. But again, as I said, the CyberEye can be deployed from a very unprepared area, a paddock, a road, So we can operate in areas where we can do our own collision avoidance by having observers out in the field as well. So we will actually put people out on the ground and being able to report by radio or cell phone as well. We've done that as well.
Your presentation today is rather jerky, but I'm assuming the video feed from the actual operation is very smooth.
Yeah, if you want to come
up and have a look on the PC, we'll keep it running. What's happening is it's the connection to the projector itself. So the actual video that we have running here is very, very smooth. It's a bit disappointing and we apologise for that. We didn't expect that. We looked at the video to make sure it would run fine on the laptop before the presentation, but we didn't look at it coming up through the projector. So it is actually very, very smooth, and you'll see just what it's like up here if you wish to have a look. You've been throwing your hand up a few times, sorry.
2.4 gigahertz, so can I blame you if my broadband drops out?
You can probably blame someone, but preferably not us. We do operate in 2.4. It's available. The technology is there. We can go and buy it and use it. We operate in 2.4 in Australia and comply with the regulations. As I said, we like to comply with regulations. We like to be totally kosher in what we do. And it's probably someone else, like some other organisation who's just set up a Wi-Fi link or something like that.
But to be clear, the 2.4 we use is just for command and control on the cyberquad, and it's all within the limitations that wouldn't interfere with anyone else's equipment. A lot of people, hobbyists, buy 2.4 video links, which are just washing out the Bluetooth and Wi-Fi. We don't go there because it's illegal to have that level of amplitude of wattage. We use 5.8 gig for video, although not as good performance. It's a legal band, therefore we're not breaking any rules and we're not disturbing people's Wi-Fi.
The 2.4 RC equipment's been available for a while now, and that's really what we're using in the cyberquad.
One of Google Earth hasn't knocked on your door before.
There's a local organisation here in Jandakot who does some flying for Nearmap as well. I don't know if you're familiar with Nearmap, but nearmap.com is something worth looking at in an alternative to Google, specifically for the for the capital cities of Australia. So is there any other questions?
Yes, Paul, do you sell it outright or do you just sell the use of it? And what's the obsolescence factor?
We sell the product, so you're quite welcome to come and buy product from us. A solution that we'll put together, or the basic product. We're developing the capability to provide the services in the future, but we need our air operator certificate and our licenses to do that. And so anyone who would buy the technology would operate under CASA Reg 101, which is not above 400 feet within visual range, no closer than 30 metres to the general public, or have a UAS operator certificate and UAS operator's license to operate in other areas.
And they would be free to do what they wish with it.
That's certainly right.
Take it out of the country and go.
There are certain limitations in regard to who we sell to and what we're allowed to sell to them, and we're very, very careful in regard to how we do that. There are restrictions placed on us globally, the ITAR restrictions, the International Trading of Arms regulations. There are also regulations placed on us by DECO here in Australia. So we can't just have any sort of approach to us for anyone to buy product from us. We actually need to understand who the people are. They have some paperwork to fill in, and that paperwork has to be approved before we even get close to providing a quote. Yes, please.
From a security perspective, it would be a simple matter to program your GPS to just disable the unit if it goes outside a certain area.
Yeah, we have those sort of capabilities built in anyway. We can set in the Cybro, we can set up fly and no-fly zones, for example. Yes, absolutely right. It also has the ability to return home. If it does have a communications failure, it will return home and land. Yeah, so there's certain protections in there, that's for sure. Yes, sir.
Actually, 2 questions. Is the innovator to deliver a package?
The payload capability for both aircraft is listed in the specs.
Around the 500 to 800 gram mark, so a small package, yes, but at the cost of endurance and like the range, you're only going to be dropping off, say, a water bottle a couple hundred metres, but the Cyber Eyes could definitely deliver a larger medical package or something like that.
That 70 kilos MTOW for the Cyber Eye includes a 15 kilo payload outside of the payload that we'd already be covering for surveillance. So that payload could be up to 15 kilos of something.
So we've been getting a lot of requests from Colombia for border use.
Yeah. We want it to go from there to there, and we don't want it back.
So the rough cost for the cyberpod?
Pods start from 20 to 30,000 as a base package with all the equipment to operate as a for basic photography or video, and then from there we offer upgrades for higher levels of autonomy or more advanced payloads like the thermal optical cameras and whatnot. So some people are spending in the close to 100,000 for a really optioned up system that does everything fully autonomously with really advanced payloads. But really just depends on the actual application and how sophisticated it needs to be.
Yes, sir.
In a few years, do you see it being able, since you can operate it in here, to deliver our lunch to our table instead of
Probably cups of coffee as well with the stability that's built in. Definitely, yeah.
Potentially, but yeah, I don't know with the way global warming is going, it's not the most efficient use of energy.
Anyone else? Yes, sir.
The cyber eye appears to me that it would be absolutely ideal for shark spotting on the coast. Has that been the case?
It certainly has. Where I showed you the photos of flying over Coburn Sound, we were actually simulating some shark spotting operations. We are currently talking to a number of people in regard to that solution. It's certainly a lot more cost effective. We have put a proposal together last year and presented it. We'll continue to keep presenting that capability. The beauty of Sharkwatch again is we can fly down below 500 feet. We can provide the separation both out to sea or close to shore. We can provide the see and avoid capability. We can have spotters. We can beam the signal directly to the surf lifesaving as well, which we've done and demonstrated. So it's a task we'd like to see the UAV doing, definitely. It's very disappointing to see that Jet Ranger flying up and down the coast at a very high expense. Admittedly, it's doing a fantastic job, don't get me wrong, but yeah, as an interim solution where we had pilots out there flying fixed-wing aircraft, yeah, it's something we'd like to see happen, and something we'd like to see happen in the short rather than long term. And we'll keep pushing for that, and we keep talking to the people, and they keep talking to us as well. We've actually we've got some video of on our system back at work with a guy on a kite surfing along, and there's a shark about, well, not very far away at all, about 10 metres away from him, with a 3 metre shark just swimming along as we're flying over the top. So it's certainly effective, and we've been able to prove the effectiveness, especially when it comes to this sort of video as well, with the capabilities of the aircraft. We like to see UAVs in the future doing the dangerous and dirty work. We don't want to take away all the good jobs. We're quite happy to go out there and do the really nasty stuff where you don't want to be flying, and it's too scary to fly, and it's just too darn boring to fly. That's where UAVs are really, really going to come into their own.
What about mustering with a hooter or something?
Mustering? Gee, I don't know about that one. You really need the guy in the aircraft for that one. Yeah. Yes, sir.
the capability of flying through a bushfire?
Sure.
We can carry an infrared sensor, an infrared camera straight away. In the Maxi, it's capable. You can launch it straight out of the back of the vehicle. You can have an immediate appraisal of the fire front using infrared. You can deploy the Cyber Eye as a overhead persistent surveillance for that particular problem.
What we've found with the plume you're probably talking about, like if you've got all the heat and smoke coming up, you're not likely to be flying in that anyway because your vision's totally just lost. So you're typically flying at a further standoff from the actual hot and windy zone. That said, it could still be quite high winds, but that's a typical, that's an issue either way. So typically you're not in the heart of the heat, you're either outside or just above or around it, and maybe upwind so you can look down and see the sort of where it's going through the bush, or the actual heat levels from above.
The fires that were recently in California, they had 25 UAVs flying at one time in that area, fire spotting, flying into the areas. I guess another thing about that is if you're in a situation where the fires were that bad and that intense and human life was threatened so badly, You don't care where you're going to fly this UAV. If I want imagery from that, I don't care what happens to it. I just want to see the imagery first, and then let's not worry about it if it goes in and gets destroyed.
Which is good business for us.
Of course. And that's again what UAVs are all about. It can be a disposable tool. Yeah, the autopilots we're developing, we have the capability of operating up to 25 aircraft from the one ground station. We can manage a whole bunch of terminals. We can send information out from the UAV, and we can have it controlled from different locations. So the technology that's growing into our new autopilot is leaps and bounds ahead of what's currently available from a commercial aspect. There's still a lot of the bigger UAVs that you see in the press. They're big because they have to carry the technology to allow them to fly. A lot of the bigger UAVs are actually flown manually. They don't go and fly waypoints and pre-programmed flight patterns. They get told to loiter, they'll get told to loiter over a point, and they'll just do orbits. But the rest of the time they're being flown manually from a pilot in a bunker or a container somewhere on the other side of the planet. The technology in regard to being consistent, reliable, needs that GPS accuracy, and that's the GPS accuracy that we've got to be able to go and do consistent missions, flying in exactly the right location, knowing that you're there. That's the technology that we're developing at the moment, and that's the steps we see leading forward in regard to our autopilot.
You're developing machines that have got a long range and can start for extended periods?
Certainly at the moment we're currently comfortable with what we're doing in regard to the endurance that we're getting from the amount of fuel and effort we're putting in. But some of the things that will help us get higher endurance and therefore longer range, and that we're watching in regard to fuel cell technology and the ability to go to electric propulsion and have fuel cells. And so we're always looking, continuous improvement. We're always looking to get that little bit of extra out of the gas that we put into the aircraft. Sorry, I'm talking American again. The amount of petrol we put into the aircraft or the amount of battery power that we put in the aircraft to give us the range and endurance. And we're seeing developments in lithium polymer batteries that are typically 2 or 3% per year in improvement in capability. We'd certainly like to see that go up into 10 to 15%. But again, we're limited in the development of what others are doing. And certainly when it comes to fuel, we're mindful of the fuels that are being developed, the biofuels, etc., and the fuel cell technology, as I said, and seeing where that takes us in regard to endurance and range. No, we're not doing much with solar. Solar is inherently difficult to manage from a number of points. It's heavy for the amount of output you get from it. So fixed installations is where solar is perfect. It's also low voltages, so you have to combine a lot of them to get the voltages that you need, and low current. So it normally can't provide the high currents that you need, instantaneous currents. They're high maintenance. There are some flexible technologies that are being developed, but they typically have to be flat and straight. And they tend to have to be pointed at the sun as well. So yeah, there are certain limitations when it comes to solar, definitely.
What are you developing military-wise without having to shoot?
Everything that we've told you so far.
Probably restricted with adverse weather conditions.
Yeah, we tend not to fly in heavy rain and hail and those sort of nasty stuff. But as I said, we can fly in pretty nasty winds at times. It's just simply the recovery and the launching that becomes a bit of an issue. When it comes to providing a solution, providing a mission capability, having to fix the UAV at the end of the mission is something you may tolerate. Breaking the undercarriage on landing, banging a wing on the ground and having to fix some fiberglass, because there's no threat to a pilot on board. You're not going to damage something as well. So you may risk the aircraft for that perspective. We've done that a couple of times in regard to operations with CyberEye, where we needed to provide the mission at the time. And that was for military type solutions.
Ladies and gentlemen, it's about time we wrap it up. It's gone 2 o'clock, but we could go on longer.